Experiment number 4. Visual classification of soils. This activity aims to classify soils by observation, determine whether it is a coarse-grained or fine-grained, perform simple hand tests, and record results using ASTM standards. Throughout the experiment, the students should be able to classify soils using ASTM 02488, tell the difference between coarse and fine soils, and write proper soil descriptions. The primary objective of this experiment was to systematically identify and categorize soil samples using visual manual procedures to provide an immediate assessment of their engineering properties. By evaluating physical characteristics such as grain size, color, plasticity, and moisture content, this study facilitates a preliminary classification into coarse-grained or fine-grained categories, a process essential for informing subsequent laboratory testing and structural design. Literature suggests that while these qualitative methods standardized by ASTM D2488 are subjective, they remain a cornerstone of geotechnical site characterization because they allow for real-time decision-making in the field. Furthermore, recent studies emphasize that the accuracy of describing attributes like dilatancy and dry strength is heavily dependent on the practitioner's experience, highlighting the necessity of integrating these manual observations with quantitative data to reduce uncertainty in soil behavior predictions. Here are the steps for this experiment. First, begin by observing the soil sample carefully. Identify and describe its color, such as brown, gray, or brownish-gray. Note any odor if present, and determine its texture by classifying it as either coarse-grained or fine-grained. Next, identify the major soil constituent, which is the component that makes up more than 50% of the sample by weight. Use Table 1 to classify it as coarse gravel, fine gravel, coarse sand, medium sand, fine sand, or fines. After that, estimate the percentage of the remaining soil constituents. Use the standard descriptors, trace for 0 to 10%, little for 10 to 20%, some for 20 to 30%, and for 30 to 50%. For example, you may describe it as trace fine gravel, little silt, or some clay. If the major soil constituent is sand or gravel, proceed with further classification. Determine the particle size distribution and describe it as either well-graded or poorly graded. Well-graded soils contain a wide range of particle sizes, while poorly graded soils consist of particles that are mostly uniform in size. Then, identify the particle shape using visual references from Figure 1 and Table 2. Classify the particles as angular, subangular, subrounded, or rounded based on their form. Next, determine the moisture condition of the soil sample. Classify it as dry, moist, wet, or saturated using Table 5 as a guide. Finally, record the complete visual classification of the soil in the proper order: color, major constituent, minor constituents, particle distribution, particle shape for coarse-grained soils, plasticity for fine-grained soils, moisture condition, and soil symbol if the soil is fine-grained. The soil samples collected from a depth of 0 to 1 meter at the same location. All samples are generally described as brown, with an earthy odor and coarse-grained texture, and their major soil constituent is consistently fine gravel. Minor constituents vary slightly across the samples, including combinations of coarse sand and medium sand in different proportions. The soils are generally well-graded, indicating a wide distribution of particle sizes, while particle shape varies from angular to subangular depending on the sample. Moisture conditions also differ, ranging from moist to dry. Overall, the classification results show that the area is dominated by well-graded gravelly soil with varying sand content, which suggests good drainage characteristics and relatively high stability, with engineering behavior influenced mainly by moisture condition and particle shape. All of the soil samples gave almost the same results, which shows that the soils are well-graded fine gravel with little coarse to medium sand. The particles are subangular to angular. The soils are moist except for soil 3 due to its location where there is ND tree shade compared to the other two. Even though the soils are strong and stable, since the results are consistent, the classification can be considered reliable for initial assessment. Thank you so much for watching. I hope you learned something today.